The Philippines is no stranger to earthquakes. With active fault lines running across the country, the threat is always there, especially for older buildings that weren't built to modern safety standards. But when earthquakes hit, it's not just buildings that are at risk. Many of these older school buildings may not be able to withstand such forces, endangering students and teachers. This is where seismic retrofitting comes in. Retrofitting strengthens these buildings, allowing them to better withstand earthquakes, reducing damage, and ultimately minimizing the risk of injuries and fatalities. To address this need, the Department of Public Works and Highways, with support from the World Bank and the Global Facility for Disaster Reduction and Recovery, launched the Philippines Seismic Risk Reduction and Resilience Project. The project focuses on retrofitting approximately 389 schools, strengthening them to withstand earthquakes and other natural hazards, creating safer spaces for thousands of learners and teachers. Retrofitting is more than just fixing cracks. Engineers assess the entire structure, adding reinforcements to prevent the building from collapsing during an earthquake. There are several retrofitting methods, each with a unique purpose. Concrete or steel jacketing involves adding layers of concrete or steel around structural support to increase strength. Fiber wrapping adds strength without adding weight, while steel bracing provides a supportive frame to absorb movement around the outside of the building. The project may employ innovative retrofitting methods using advanced technologies, such as seismic isolators and dampers, base isolators, like flexible rubber pads or slide bearings, are placed between the building's foundation and the structure above. This allows the building to move independently of the ground during an earthquake, thus reducing the amount of shaking felt by the building, protecting it from damage. Dampers, like shock absorbers in cars, are devices installed in buildings between floors and walls to reduce vibration and damage during earthquakes by dissipating seismic energy. These solutions usually do not require interruption of the building operations and evacuation of occupants. However, the applicability of these techniques depend on site and building conditions. In addition to these retrofitting activities to keep the school safe, additional functional improvements are being made to add needed facilities, like additional washroom facilities, inclusive accessibility features, and additional multi-hazard resilience features, such as flood and typhoon resilience measures. But will retrofitting disrupt classes with noise and dust? Well, there are ways to reduce these impacts, such as the use of sound and dust barriers and limiting noisy work to certain hours. These will be recommended as part of the Environmental and Social Management Plan, or ESMP. In addition, open consultations with stakeholders will inform the creation of a learning continuity plan or student relocation plan to ensure that students' education continues smoothly. Retrofitting is an investment in safety and resilience. For schools, it means secure learning environments. By investing in retrofitting today, we're creating a future where schools aren't just places to learn, but places that stand strong, even when the ground shakes.